Well, good afternoon, everybody. And our company is in Puerto Rico, Sabana Seca, Puerto Rico, and in our factory that makes the panels and also the structural mortars as well. We're located in Long Beach, Mississippi. That's Gulf Concrete Technology up there. And today we're going to be speaking about the expansion of 16 structures with these SCIP structural concrete insulated panels. So in our agenda today, we'll be discussing a project where we did some expansion due to some repairs due to hurricane winds tearing out the roof of this structure, and so we'll discuss what's the SCIP system a little bit, how the mesh connections are made, and also how you connect to the existing structure, and also how the dowels are anchored to the foundation. We're going to see some roof connections of the existing structures with the panels, and also how do we use our machines like the MTEX, Monomix to let's say shotcrete the mortar to the walls, or let's say the ceiling. And then after that, then we'll be open to some questions. So this system is let's say the structural insulated building component, or SCIP, structural concrete insulated panels. Are made in two different forms. One is with the EPS, with the PSM components, where you start off with the EPS, expanded polystyrene core, and those are used, let's say, mainly on walls, and also you can use them on ceilings. That's the one here on the left. And wherever you have spans in rooms up to, let's say, 12 feet, you can use PSM components of these types of panels. Then the foam is covered with a steel mesh. This steel mesh is galvanized, and it's like, let's say, 95 KSI. So it'll have mesh on both sides of the foam. Okay, and then that is also covered by a structural mortar, right? This mortar is 4,000 psi, and it also comes in bags, 50-pound bags. And you can, let's say, shotcrete the mortar or spray the mortar on each side of the panel. If it's a wall, or if it's a ceiling, then underneath that ceiling, and then over the panel, you're going to be using, let's say, concrete, let's say 3,500 psi concrete. Okay, so after the structural mortar, then it's covered, let's say, either by, you can do another mortar, let's say, for finishing, stucco. You can also use a synthetic stucco to do that finishing as well. So there's a variety of finishes that you can do there for walls or ceiling. Then on the right here, you're going to see the PSG component or panels. This will create, let's say, a T-beam pocket here. And for every, let's say, these panels come in 4 feet. And so for every 4 feet, you'll probably have, let's say, 2 girders, 3 girders, or 6 girders open. So that's where you're going to be placing two half-inch rebars on the bottom here, not touching the foam. You can put some chairs, plastic chairs over that. And depending on the panel you're choosing, right? If it's a PSG 2, 3, or 6, you can go up to a span between walls of 32 feet without any beams in between them. So the difference between the PSM and PSG, so let's say it again, it's PSMs are used for walls and also ceilings, or let's say rooftop, or in between floors up to, let's say, a span of 12 feet. And the PSGs are used only on in between floors and roof up to a span of 32 feet, okay, but without any supports in the middle. So that's the difference between these two panels. And so the mesh already comes in with the foam, and these are made in Long Beach, Mississippi. So the panels are 4 feet by the height of the, let's say, wall, or 4 feet by the length of that span you want in between the, let's say, shear wall, or that in between those walls as well. So the length will be up to 32 feet. For the PSMs, you can do, let's say, up to a 20-foot high wall, but we prefer to cut them in between slabs, so let's say 10 feet each. That would be much better. And also to transport or to do the application or installation. So we also sell the connection mesh, okay? And we have, let's say, if it's between two walls, right, interior walls, you'll be using here L meshes, right, these angular mesh. and that's what's connecting the panels in those corners, right? Or if it's a slab and the wall, you also be using these meshes that they'll probably be 7 inch by 7 inch, right, on these angles. And if it's an exterior wall, right, and in that joint between those walls that are joining, that mesh will be, let's say, about a foot, 12 inches, and then the other side will be like 7 inches. So that's where we use the long L mesh. Okay. Also, we also have the U's, and depending on the size of the panels that you have, let's say you have a PSM 80, which is 4 inches wire to wire. That's the thickness of that panel. So you probably use an RGU 80. And these are used, let's say, all around the perimeter of the windows and doors. That's what you're using. Or let's say you have a wall where it just ends there, and on that perimeter, then you're going to be putting that U mesh. You never want to put some mortar over foam without any mesh over it. So you have something anchoring that mortar to that wall, right? And also, we also produce the flat mesh, which is here in the bottom. These come, let's say, in 15 inches by 4 feet, and these are used, let's say, let's say if you make a cut in one of these walls, and you have to cut the mesh, the original mesh that comes from the factory, then you can put these flat mesh and clip them over the existing mesh. And yeah, these clips are clipped in there with a hog clip gun. All right, okay, you can buy those in Amazon. They're about $210 each, and you can also buy the clips there as well. So let's say every 2 squares, you'll be putting, let's say, a clip to anchor those meshes to the existing panels. Then we also produce panels that are 4 feet by 8 if you need them, or 4 feet by 4. 4 feet by 4, we use them, let's say, as splice meshes, where let's say you have a PSG up to, let's say, 20 feet, and you want to add 2 feet or 3 feet to that roof. Then you can also cut them in the field, and you can put a 4 by 4 mesh over and under that panel, right? And so that's where you do a splice mesh. So in that joint, you'll have, let's say, 2 feet on each side with that 4 by 4 mesh. So here are some examples of how they look like. These are the top one. Here's a flat mesh. Here you have a U mesh here, and then your L mesh is on the bottom. Okay, and these are some of the places you can use these flat meshes. We use, let's say, 2 feet by 7 inches. You can cut them there. If you get, let's say, a 15-inch by 4 feet mesh from the factory, right? You can cut those in 4 pieces, and those 4 pieces will go in that at 45 degrees to that corner. So that you can reinforce any movement there, and you don't have any future cracks there. Also, if you, let's say, cut, let's say, the wall, you can also, let's say, mend or fix that. If you cut the original mesh, you will fix wherever you cut with that flat mesh. Okay, it could be horizontal, vertical, and so let's say you're putting a pipe, electric pipe, or plumbing. You probably might cut, or if you use a flexible pipe, you might not need to cut, those areas. So, and then in the corner, let's say here's your corner of the in between walls. Then you're going to use an angular mesh, a small one, 7 by 7, there in the interior, and then in the exterior on the outside where you're going to have the joint. And that side you're going to put the 12-inch side of that mesh, and then the smaller side on where the joint is not located. Okay, so that's the other mesh we use. And also here the U meshes are used in all the perimeter of the windows and doors, as you can see here, and that's to reinforce those corners. We usually leave like let's say 1 inch between the foam and the mesh, and then you can form this with a 2 by 6. Okay, and then you can form it so that you also have whenever you, let's say, spray the structural mortar, then you have an edge about 2 inches of structural mortar, so that you can anchor your windows and doors to those areas. Okay. So where do we anchor these panels to the floor, and how, right? So let's say this is your foundation here on the right. We do recommend that you can drill a hole, right, and go down, let's say 7 inches, and instead of having the rebars coming up these dowels from the foundation, you can drill them. So you can finish your let's say your foundation and floor first, and then you can come in and measure from the, let's say, from the side, the exterior side of that building, let's say 2 inches, and then put your first rebar, then mark, let's say 4 inches. And if you, let's say if you're using a PSM 80, then you just mark 4 inches from there, and then that's where you're going to do the drilling of those holes. So how are these holes are located to do that, right? So before I go to the next diagram, so you drill the hole 7 inches. So that's how you're gonna, let's say, put epoxy in there, and then put the rebar. Then that rebar should be over the surface of the floor about 18 inches high. Okay, and that's with a technical evaluation report. That's doable, right? That's how our system is designed and tested. And also it's tested with a 3/8 of an inch rebar, number 3 rebar. So that could be just enough to for those buildings. Okay. So how do you space these rebars out, right? So let's say you start in the corner here, and then every 16 inches you're going to be drilling a hole, right? And that has to be so inside the mesh of that panel, right? It has to be inside. So that's where you want to have your rebars, okay? So then on the other side, it's going to be staggered, let's say 8 inches from the first one, right? And then spaced out every 16 inches. So every 8 inches, you're going to have a rebar in your let's say wall or on these panels, right? So this could be on let's say on the floor, or it could be on a beam, sorry, on a column, so that you want to join to a, let's say, or let's say a structural wall, a concrete wall, structural concrete wall. You can make also these holes, and that's how you're going to be connecting to the walls, to either a column or let's say a beam as well. That's how you connect. But again, these systems the system has to be designed by a structural or engineer or an architect, right? And you have to have some design before you install these systems, right? So once you have your rebar, okay, you start. Let's say you're doing a wall. You start off from a corner, right? And you just put 2 panels up. These panels come in 4 feet by the height of the wall, okay? And so you'll be putting one next to the other, and each panel comes with a, let's say, 2 square flat, okay? So there'll be an overlapping here on each side of the wall, and that's where you're going to be putting your clips, right? No additional meshes is needed when you're putting one panels to the other side by side there. Okay, so this is the way the dowels is distributed, and then once you put it on the floor, or let's say if it's on the wall, then you'll be anchoring those the wall there. So once you put your panels on the floor, right? You need to use some wire. You need to tie it up with some wire, okay? There, just with one is sufficiently, And also you need to melt the surface, at least have an inch behind these rebars, so that when you apply structural mortar, you're protecting the rebar with mortar. So there shouldn't be any rebar touching the foam or the EPS. Okay, there are different types of heat guns out there. I mean, we specify that these heat guns have, let's say, 1,000 degrees Fahrenheit. Okay, but they both will work. Any brand will work. I mean, that's what we're saying here with this picture. And so how do we do the connections between existing structures and these panels, right? So here is what our engineer drew for us here. This is the existing wall here on the I'm discussing here the one on the left here, the dowel anchoring to the concrete wall. So this is the existing wall here, and so we'll be putting our dowels in there, right? Whatever the structural engineer says that we have to embed that rebar in there. And in this case, they put, let's say, a foot or right into the existing structure. Okay, and that's the way you'll be putting your rebar on it. And then these rebars are going to be staggered in that wall, right, in that structural wall. And the one, this picture on the right is the panel. So you'll be putting your panel here, and let's say if it's the wall, and that's how you connect there. Or if it's a existing slab, or again, it has to be a structural slab, okay, to connect. You can't connect to let's say a block of walls. It has to be either a beam or a column or a structural wall to connect these panels to. So minimum, let's say this is a roof, minimum, or a wall, minimum you need 3/4 inch of structural mortar on each side, okay? 3/4 inch. And the way we do that is we put a pipe as a guide that has a diameter of, let's say, a 3/4 inch, and you space them out, let's say, every 3 feet. Then once you put the mortar, you'll screed up and fill that gap with structural mortar, and then that's 4,000 psi mortar. And again, these dowels have to be epoxied in. I got some contractors where they would, let's say, drill the holes and then leave the rebars in our panels, then join, put the panel next to the wall, and then epoxy in the hole, and then just slide in the rebar. Okay. So if you look at the section, this is what it looked like, right? This is your wall, okay, and you got your staggered holes there, okay, and then once you place the rebar there, I'm sorry, hit the wrong button there. Then you place your rebar inside the hole with the epoxy, okay? And do that, just slide it in. And these, the engineer wanted it, these number 4 or half inch rebar, they want them staggered every 12 inches. I mean, or spaced out every 12 inches. So they'll be staggered at 6 inches here in between. Okay. So let's talk about this project. This was a project where they did the repairs in Puerto Rico, and it was after Hurricane Maria. So this is how the house looked before Hurricane Maria, and after Hurricane Maria, they had block walls, concrete columns, beams, but the roof was made of wood. Okay, and part of it just came out, right, with the high winds. We had high winds about 175 miles per hour to 200 miles per hour in some areas of the island over here. And then when they started remodeling the house, right, to do the repairs, they took out all the roof, all the wood out, and all the windows. They took them out, and so they can refresh the structure. Okay, and they wanted the walls a little bit higher, so they added, let's say, 2 feet on the walls with our panels. And you can see here our rebars, right? Every 12 inches in this case. That's what the engineer wanted. And these are number 3 rebar or half-inch rebar, depending on the design. Okay. So how did they connect the roof to the existing structure, right? And here's a layout, right? Of this is your existing blocks, all right, wall, and then had a beam, right? So they drilled a hole and they put a rebar, okay, here, and so that they could anchor the panels on the roof. So you can see there they did an L shape later on here, and so these are two number 4 rebars they used, and the dowel was number 4, and that's kind of hard to bend. 3/8 of an inch is easier to bend than number 4 rebar, but that's what the engineer wanted. And here you can also see the side anchor of the concrete beam using a PSG panels. They also use PSG panels. So that's the one that has the U, where you can put 2 half-inch rebars. And these are the what we call a bond beam, which they made or they formed in place. And so you have your half-inch rebars on the bottom, okay, of that U. Okay, sorry, and also you did some L shapes into that U as well, and added, let's say, 3 feet additional anchoring into that U of that T beam. Okay, inside our panels. So that's how they did the connection with the bond beam, and then after they placed the concrete, which is about 35 psi, right? minimum that it should be over the mesh about 2 inches. And then if it's not, if it's you don't have a huge slope, then you have to at least do, let's say every foot go up a 1/4 inch. So probably in the middle of that building, it'll have 5 inches over the mesh, right, of concrete, and then on the side of that building, it'll have about 2 inches, which is the minimum we require over the mesh. And this is how those L rebars that are anchoring to let's say the roof. Let's say if I go back here, see how they anchored here to that beam. This is where the beam was at. And so they bent the rebar over the panels. See, they did additional reinforcement of the mesh. You can say this is like a splice mesh here when you're adding more say flat mesh over that. And here you can see on the side how they connected to the existing structure with the staggered rebar every foot, you know? And over here they did more reinforcement as well on the top and bottom of the roof. So this is how it looks on the bottom of that roof, right? They connected the rebar, they drilled a hole to the let's say this could be a shear wall, this could be a beam, okay? And so they drilled a hole in there, and they embedded the 1/2 inch rebar. And you melt around where the rebar is, so that when you spray the structural mortar underneath that roof, then you have enough material there to anchor around that rebar, okay? At least an inch around that rebar. You have to separate the foam from the steel. And this is the PSC anchoring to the concrete beam. Here you can see the beam there that they'll be forming, and they're forming it right now. It's very important before you walk over these panels that you have your supports, say 4x4 with steel columns in there. At least, I mean, these 4x4, you got to space them out every 4 feet minimum, right? And then they should be going. Let's say if the length of the panel is going this way, then that means your transfers to that length. You have to put your supports, okay, going down this way. Okay, that's very important. Then on the right here, you can see the bond beam here. Okay, they did additional reinforcement. And you can see the PSG panels, right, where this would be the U going down. This is where you're going to have your 2 rebars going down, and they use these 3/8 of an inch U's, so that it doesn't touch the bottom. It's like kind of your chair at the bottom there of that foam, right? So you have 2 1/2 inch, plus you have negative rebar on the top. They added. So. And again, this was a design by a structural engineer or an architect, right? Here you got a closer how you can see the rebar, the 2 1/2 inch rebar going in to the bond beam at the end of that. This would be your 3/8 of an inch rings or hoops, and you probably have like 4 1/2 inch rebars on that beam, okay? And then you're forming it. So once you place the concrete over this panel, then you'll also form the beam in there. So it's all monolithic. Then on the bottom side of those panels, you'll be putting, let's say, L meshes underneath. You can see it there. They put some L meshes between the walls and the roof or the ceiling right there. You got your L mesh there, okay? And your rebars going up every foot, if that's the design, or every 16 inches, depending what the structure is saying, okay? You can also connect to steel beams, like here. They welded the rebars, right? So this is where they welded the rebar, and then they were going to bend it over the panel. Okay, and that's over here. They got another beam going in this direction, and they'll bend these rebars over the panel. So once you have, let's say, all your panels placed, all your meshes placed, the L mesh, the U mesh, the flat mesh, and also if you have some electrical conduits or plumbing conduits, you have to place them first. Your electrical boxes, you put all those first, and before you place the mortar. That's very important. Sometimes they don't listen, but it happens that some places you don't put your pipes together before you put the mortar, and then you have to come back and open some areas. So you got to make sure you have all your plumbing and electricity in place first. I mean, the wire is not necessary until, let's say, afterwards you finish the mortar part, but at least have your conduits in there. So how do we apply the mortar? We use these machines, the Monomix, and these are very versatile. The Monomix it's a 240 volt machine with 30 amp breaker, and it comes with this is your hopper where you're going to break your 50-pound bag, let's say of structural mortar. It'll feed it here, and it also has a sleeve which this will last, let's say, for like 10 pallets, let's say 800 bags to 1,000 bags. Then you have to change these stators, and then it has a rotor, also another rotor in there, and that's practically your pump in there. Okay. It also comes with a compressor and also a gauge where you can connect it to your water hose, and this will feed, let's say a gallon per bag of water. So you adjust it here, and since you almost need, let's say, a zero slump mortar to do your, let's say, walls and also ceiling, so you can do those adjustments with the water with this machine. And it comes with a, let's say, a 32 feet hose and also a mortar sprayer as well. So in brief, I'll show you that one. The machine here, the Dual Mix on the right, this one can do like let's say 85 bags an hour. Your Mono Mix can do, let's say, 60 bags an hour. The Dual Mix is a 3-phase volt that requires 480 volts. So to have, let's say, 3-phase in electricity in your building, or if it's a residential area, it's going to be kind of hard. But you can move it with, let's say, a 16 kilowatt generator, versus a Monomix you can move it with a 10 kilowatt generator. So that's why we sell more of these Monomix. So now we're ready to, let's say, apply mortar, right? And let me show you. The first thing we do is we spray the mortar on the walls, because we want to make those panels stiffer on the walls first. Okay, and then we do the ceiling part, and then we do the ceiling. Make sure all those boxes are covered with tape. You cover them before you start spraying mortar. And also we put guides, let's say 3/4 inch diameter exterior pipes every 3 feet, so that you have a guide, let's say, on the walls and also on the ceiling as well. You can see the pipe here. This picture is sideways, but this is a video I'm going to show you in a minute here. So once you sprayed the walls, and now you're ready to spray the ceiling. And the best way to spray the ceiling is in 3 steps. So first, you just spray it real light, and then just finish that room, and then come back again to the other end and where you started, and then finish all the way up to the mesh, and then put your guides. You can see the guide there. We strap it with a tie wrap, and let me show it again so you can review it. So the ceilings are done in 3 steps again: for light spray, then up to the mesh, and then you put your guides, and then finish the 3/4 inch underneath the ceiling as well. So this is a 4,000 psi mortar. So once you finish applying that structural mortar, then you can do your finishing. What we do is you can see here on the photo on the left, where we take, let's say, an adhesive trowel, a notch trowel, right? A 1/4 inch by 1/4 inch, and we make lines left to right, okay? And this will create a mechanical bond for your next finishing mortar. Let's say we can apply, let's say, 3/8 of an inch of that mortar. In the States, most of the time people are, let's say, finishing it real flat with the structural mortar, and then spraying a coating over it, a synthetic stucco, let's say, right? So again, the structural mortar should be applied with 3/4 inch over the mesh, okay? And if it's a wall, on both sides of the walls, and if it's a ceiling, then just underneath the ceiling, okay? Then to achieve that 3/4 inch, we use those pipes are 1/2 inch interior, schedule 40, okay? And that will have a 3/4 inch diameter in the exterior. So that's what we use, and then put those every 3 feet on the walls, and then that will serve as a guide. And then you do the mechanical anchoring with the adhesive trowel, okay? And that way you don't have to use any bonding agents, okay, to do the finishing. And so if, let's say, you're using a 3/8 of an inch finishing mortar. That would be a Type N mortar, which is about 750 psi is a Type N mortar. But we also have 1,000 psi, and then we also have Type S mortars, which is about 1,800 psi, and also Type M mortars are about 2,800 psi. But since this is just for aesthetics, with 750 psi is enough. So that's why we recommend a Type N mortar. So here, once we do all the finishing, right? We do the structural mortar, and then we do the finishing mortar at the end, and this is how it's going to look like. Okay, so nice and flat. Okay, so here you can see the before and after. Before the Hurricane Maria, and then after the remodeling of the inspection of this structure with the panels. So how beautiful it's looking there. Here's some more photos on the other side of this building, of the house. It just completely looks different and more modern. Okay, so they didn't have to tear up all the walls, and so they were able to use the walls and some of the beams, and then work it from there with the panels. But again, you need a design by a structural engineer or an architect to get this properly a good design. So this is how finally the house looked like, and it came out just a beautiful project. And Carmelo, we manufacture many cementitious mortars, self-leveling, hydro plugs, structural mortars with let's say corrosion inhibitors. We also have thin sets, blocks, retaining walls. But in the States, we're just working with Gulf Concrete technology on our, let's say, structural panels, the SCIP system, structural concrete insulated panels. That's where we make them in Long Beach, Mississippi. So we're open. You can open your mic if you have any questions. We can take them right now. Rob, Jorge, Chris, Mark, any questions? Yeah, we are.
It's Jorge. Hello, how are you today?
I'm doing good, all right?
Do you have a set of drawings, digital drawings that you can distribute?
Yes, we can. If you can send us your email at info at, we can send you, let's say, our technical evaluation report. We can send you the drawings that we have in DWG and also PDF of giving you details of what to put in your structural plans, yeah, or detailed plans.
Can you repeat the email? Can you repeat that?
Oh, it would be info@carmelo.com.
Thank you very much.
Sure.
Thanks.
Yeah, and in our website in GCT Structural Panels, you can also get there the technical evaluation report as well. That's what we call the TER. And the TER is basically all the, let's say, testing DRJ did and certifies that it complies with the U.S. building code and also the Puerto Rico building code. So we did, let's say, all the flexural shear, let's say, moments. You can find it there, and they also provide, let's say, tables where you can select the panels as well. They did a pretty good job with those tables, where you can get, let's say, the lateral loads, and how high the wall are. And so these panels come from, let's say, PSM 80 to a PSM 240. 80 means in millimeters, right? So they come, let's say, from 4 inches to 10.5 inches, from wire to wire. Okay, and the basic dimensions 4 feet by the height of the wall, or if it's the PSGs, up to 32 feet, like I mentioned. But there always will be 4 feet by the length. And then the thickness, you will need to select it by the technical evaluation report. Well, if we don't have any other questions, I think we're done for today. And I really appreciate you coming in and sharing your time and to get some knowledge on these structural concrete insulated panels. And yeah, go into our website, and also in YouTube we have several presentations on GCT, so you can look it up as GCT Structural Panels Carmelo, and you can see videos and presentations that we have there for the panels and other materials as well. Also, in Carmelo, you can go into, let's say, carmelo.com, and you can also look at what materials we make there as well, and in GCT Structural Panels website.
Hello, I got a quick question.
Okay, Rob.
Yeah, what's the why is one arm called GCT and the other one's Carmelo? I'm not.
Yeah, Carmelo, GCT is owned by Carmelo, It's a group, and so GCT is our company, our sister company in Mississippi. Let's say
Okay, but the
Yeah,
main company is Carmelo because it's like if
Carmelo,
you
right?
look at your
Yep.
website or if you go to YouTube to view videos, all the Carmelo videos are Spanish. So
Yeah, that's mainly for the Puerto Rico market. But yeah, if you go into the structural panel, GCT, that's mainly in English. Yeah.
okay, and the other question I had, like when you're doing the concreting, you say that the first layer or the scratch coat should cover the mesh by how much?
3/4 of an inch.
Okay, so but like say if you're spraying your concrete, you're not going to spray it to 3/4 of an inch over the wire mesh the first go, right? You're going to do it.
Yeah, if it's over the panel, I mean, as a roof, if it's a roof panel, then it's going to go 2 inches over. But that's going to be concrete, 3,500 psi concrete over the panel, which you have to call
on,
your
on,
local ready mix producer.
on the top or
Yeah,
under?
on the top.
Okay, but when you're spraying the ceiling inside the house,
Oh, okay. Yeah, that'll be your structural mortar, and then it'll be you have to put the 3/4 inch underneath that mesh.
but is that all at one go, or do you wait for the first part to solidify?
Yeah. You can apply it in three passes. You can do 3 steps. Real thin, and then up to the mesh, and then put your pipes that have the 3/4 inch diameter, and then that'll give you the 3/4 underneath the mesh.
But
As a
that's
guy.
a scratch coat for your finishing coat. Then you want to say it could be as little as a 1/4 inch.
Right. As a little.
So I mean, if you've got those plastic pipes in there, why wouldn't you use that to finish like? Is there any
The,
just
just the structural mortar, just to keep you as a guide for that 3/4 inch.
right?
You,
I
and
get
then
that.
and then you take them out. You have to take them out.
No, I realize that as well. But I mean, couldn't you just finish the concrete to that level with the plastic pipe? Do you need to put another coat on after that?
Yeah, the problem with the structural mortar is, we try to make this material so, let's say, let's say, cheap, let's say, where it has a lot of cement and also has fibers, but some plastic shrinkage will appear there, or cracking, and so that's why you want to cover it either with the synthetic stucco or a thin layer of finishing mortar, which is the type N.
So then you absolutely have to have the 4,000 psi concrete 3/4 of an inch over the wire mesh,
That is correct. Yeah.
and then you can put a finishing concrete or silicone or whatever kind of coating you want on after that.
Yep.
Okay, got it.
Okay.
The same thing with the walls, you do the same thing.
Right.
And so probably what a guy would do is like with those plastic pipes, you'd spray your mortar on till you get a little bit over that, then screed it, and then put your scratches in there afterwards so that you can apply your finishing whatever concrete or whatever afterwards. Is that correct?
Yeah, I mean, you can on the walls, you can finish it all the way up to the pipe, the outer side of that pipe, which already has the 3/4 over the mesh, right?
Yeah.
So when you screed it, then you just make the lines on it and just leave it there, and then you can finish it with that either 1/4 inch or 3/8 of an inch of type N mortar.
So the type N is 750 pounds. You're going with that softer or
Yep.
mortar because it doesn't crack as much. Is that the idea?
That's the idea. Yeah.
Is it easier to finish as well?
It's easier. It's easier because it'll give you time to finish it with the say the trowel and then the sponge, and then it'll finish it better.
Yeah. Yeah. Go ahead. Sorry.
And also that all these mortars have plastic fibers as well to control the shrinkage, cracking. Yeah.
So what kind of fibers is it? Like fiberglass?
It's plastic. It's plastic.
And you think that that's better than fiberglass, or that's just what you guys sell?
Yeah, that's the most of the industry sell. I mean, like even for your regular concrete, if you ask for them for fiber, that's what they're going to put.
Oh yeah. See, again, my problem is because I'm in Canada and we get like upwards to -50. And so, we want to mitigate as much water penetration as possible.
Right.
You know, I would even like to is your 4,000 PSI mortar, do you have a waterproofing additive in it or anything like that?
Well, the water cement ratio there is real low, so you're gonna have real dense mortar there. And we also have testing on waterproofing of our system. So, I mean, this is gonna have like 2 inches of mortar on your exterior. That's more than enough to hold the water out.
Yeah, well, I mean, the concrete acts like a sponge, so the water's going to
Yep.
stay there,
Yep.
right?
So let's say for the roof, if you have a flat roof or a slopey roof, right, and it's a concrete, then we recommend you seal it with, either silicone or, whatever method you guys want to waterproof it with. On the walls, you'll probably use a synthetic, let's say, paint over that, okay, and that's
But you don't
so.
have an additive that's in the concrete that will help with the waterproofing of the concrete itself?
No, no, not for this product.
Okay,
Yeah, because we do have one, but that one, the paint doesn't stick to it. Yeah, because hydrophobic. Yeah,
right,
that's the problem. So we would sell it to you either gray or white.
got it.
Yeah, we use it more in foundation. Or
Is that your own ad mixture or is that from a different company?
it's our mixes.
Well,
Yeah,
because
our mix designs. Our mix designs.
I know there's a new company, and I think we talked about this last time, and you guys
Mhm.
said you would do some testing with it to see if it would work with your concrete. How do I guess I just got to get a hold of Scott and arrange something where I send some additive down to you guys and you can do some testing on it
Yeah, yeah.
and
We can take a look at that.
see if it's paintable or not. I don't know, like, so you can't even with your additive, you can't even add like you were talking about a silicon base or a latex based, like a stucco. That won't stick either.
Yeah, I mean, because again, it's hydrophobic, so it will. I mean, it's going to be hard to stick on it.
Is that
So
okay?
yeah,
So if
that's
you
where.
go with that, you're just going to be stuck with a concrete finish, which I'm okay with. I mean, I like the look of concrete anyways, but yeah, I never considered that. That's something new. All right, well, I'll let you go. I will maybe have a conversation either with you or I guess
Got it.
Scott. You
All right.
want to handle that or
Sure.
okay?
Either or is good.
Get further down the road, but this was very good. Thank you as usual. Very good job. I learned something more every time, so it's
Great, great. That's the idea.
thank you very
All
much.
right. Thank you for coming. All right. All right. So any other questions? Are we good? Okay. So thank you very much for your time and have a safe day out there. Okay. Take care.